Welcome back to the chapter 6.3 notes on triangles. We are going to start talking about the special right triangles. We will use this moving forward in this class as we build the unit circle. It's important that you understand the relationships here. Okay, so the first special right triangle we are going to talk about is an isosceles right triangle. An isosceles right triangle is both isosceles, which means both legs are the same length. It can't be a leg in the hypotenuse. Hypotenuse has got to be longer. And we've got a right angle. Okay? So we are going to go ahead and start by labeling our two sides the same way. So A and A. Here's my hypotenuse C. Why am I labeling them A and not A and B? I know they're the same length, so A represents that same size. If I combine both, I get 2A squared equals C squared. I can go ahead and take the square root of each side so that I can solve for C, and C is going to end up being square root of 2 times A. 2 is not a perfect square. I'm leaving that under the radical. A squared is a perfect square, though. So any hypotenuse in an isosceles right triangle is the length of the leg multiplied by the square root of 2. Therefore, we only need one of the three lengths to determine the other two lengths of the sides. The ratio is usually written as x to x to x square root of 2. Notice here I'm putting the number part after the variable. It's really easy if we write square root of 2 times x to make it look like that x is underneath the radical, but it's not. Okay, x is the length of the legs, x square root of 2 is the length of the hypotenuse. So we have some examples with isosceles right triangles. If you feel like you got a handle on this, this is a great place to pause, or after I go through the first example, give it a shot and then come back and compare. So A, if one of my legs is length 8, my other leg is length 8, and to get from the leg to the hypotenuse, we're going to multiply by the square root of 2. I get 8 square roots of 2. I am leaving it like that. The square root of 2 is an exact value. I definitely don't want a decimal approximation. B goes the other way. We have the hypotenuse, we're trying to find the legs. Well, if we know we multiply by square root of 2 to get from a leg to the hypotenuse, we got to go the other way and divide by square root of 2 to get from the hypotenuse to a leg. So I've got 7 square roots of 2 divided by the square root of 2. My square roots of 2 cancel. I get legs of length 7 for triangle B. C, again, we have the length of a leg. It is 10 square roots of 2. So I know my other leg is 10 square roots of 2. To get to my hypotenuse, I got 10 square roots of 2 times the square root of 2. 10 times the square root of 4, if it makes you happy doing it that way, which is 10 times 2. So the length of that hypotenuse is 20. D looks a little different. We got to get a little more creative. We've got the hypotenuse, 9 square roots of 6. We are dividing by the square root of 2. I get 9 square roots of 6 divided by the square root of 2. Remember that we can break a fraction under a radical apart into 2 radicals, and we can combine 2 radicals as a fraction together. 6 divided by 2 is 3. I get sides of length 9 square roots of 3. Both legs. We also know that in an isosceles right triangle, the angles across from the sides that are the same length have to be the same measure. I have got 180 degrees minus 90, that's my right angle. I got 90 degrees left. That 90 degrees has to be divided evenly between the two angles. I get 45 degrees. So the angle measure in an isosceles right triangle is 45 degrees, 45 degrees, and 90 degrees.